Hello, everyone, and welcome to the session on scalability in Azure networking. My name is Mohammed Hassan, and I am a principal product manager in Azure networking. Today, we will talk about scale. How do you scale your workloads in Azure? And before we dive in deep into how you scale your workloads, we will start by talking about the scale of Microsoft or Azure cloud. We have up to 70 regions and 300 data centers worldwide connected through 360 kilometers of fiber and 2 petabytes plus of WAN bandwidth or WAN capacity. Now, let's talk about how do you as a customer scale your workloads in Azure. When we talk about networking in Azure, we split it into 4 pillars: foundation, connectivity, application delivery, and security. And whether you are migrating to Azure from on-prem or whether you already migrated and completed your migration and are working on modernizing your platform, or if you're cloud native, scale requirements varies depending on each stage. And we will dive into each of the pillars of networking and what's the best practices for scaling your network, and also what are new innovations we have introduced in that space to help you scale in Azure. Let's first dive into the foundation pillar or the foundation scale. For foundation scale, the best practices is think of virtual network as your building block or as a foundation unit of scale. And you will scale your network by stamping multiple of the virtual networks. What is critical there is to think of IP address planning using IPAM. And we have a native service in Azure, which is Azure Network Manager IPAM, that offer you IP address management, or you can use your own IPAM. But it's critical to plan ahead for your IP usage and consumption for VNet so that you don't face later issues with overlapping IP addresses. And in the case where you have mergers and acquisitions, where you have to deal with overlap, we have different recommendation architecture center on how to use or how to deal with overlap. Additionally, when connecting a virtual network, we recommend using the native VNet peering and global peering or vWAN to connect to your virtual networks in Azure, and avoid using ExpressRoute hairpinning or sending on-prem Azure traffic to connect VNets together, because that introduces latency and performance impact. Instead, use native capabilities. Similarly, for outbound, we have multiple options like IP address, outbound load balancers, and NAT Gateway. And the recommended one is to use a NAT Gateway because it offers a scalable Azure managed solution for your egress. You don't have to deal with outbound static exhaustion, and you don't have to deal with auto scaling your outbound. Finally, if you're connecting to PaaS services, we recommend using Azure Private Link as a default for connecting to PaaS because it gives you private connectivity, and it also gives you data exfiltration prevention. And you can also offer your service using private link service. So if you have a service you want to offer to external customers, or if you have a service you want to offer to your internal teams, you can use private link service for that to offer it privately at scale. Now let's talk about innovations in the foundation space. And the first one I'll talk about is private link scale. Now you're able to create up to 5,000 private links in a VNet and 20,000 in connected VNets. And that is like 20x what we originally offered to give you ability to scale your private links. And we know because private link is based per resource, and we hear the feedback from customer on the need for scaling that up. Additionally, we have introduced zone redundant NAT gateway, which simply instead of having to create a NAT gateway in each zone, you can only create one NAT gateway, and it will have zonal redundancy by default built in. You can attach it to one or multiple subnets to offer egress to your network. And also, it gives you 3x the bandwidth of current NAT gateway, in addition to IPv6, which offers 6-to-6 NAT support, in addition to the existing 4-to-4 support. Also, in the control plane, we have done enhancements to improve the network, the create and delete of virtual machines. So we have offered improvement of up to 5x in create operation and up to 50x in delete operations. Additionally, we introduced prefix on NIC, which allow you to add additional IP prefixes on a VM to reach out to 1 million IP addresses in a VNet. For primary addresses, we have 64K per VNet and 256K for peered VNets. Now let's dive into the connectivity scale. And connectivity is when you connect VNets within Azure or connecting VNets back to on-prem. And the recommendation there, or the best practices for scale, is to use a hub and spoke architecture when feasible, and make sure you have regional hubs instead of using global hubs, because regional hub allow you to have isolation, and also you can centralize the workloads in your hub, like private links or firewall, and you can create hub and spoke using VNet peering or using Azure Virtual WAN. Both are options available. Similarly, for ExpressRoute, for connecting on-prem, ExpressRoute for connecting to on-prem, ExpressRoute is recommended private, low latency way of connecting to your environment. And we recommend using auto-scalable gateway if you want to use ExpressRoute gateway, and it can scale up to 40 gig of bandwidth. Similarly, if you have high bandwidth requirement, for example, moving a lot of data from on-prem to storage for bootstrapping purposes, or for AI training purposes, you can enable FastPass on ExpressRoute. That will give you high performance access to storage and to other services, or even higher access to high bandwidth to VMs over ExpressRoute. Finally, there are one of the critical things when think of ExpressRoute is picking the right SKU to meet your skill needs. So we have the standard and the premium, and this gives you, we have the local standard and premium, and they give you different reachability and different bandwidths. So depending on your requirements, you can choose which SKU fits you and plan for your network scale. Now, let's talk about innovation in that space. So we recently pre-announced 400 gig ExpressRoute. That's 4x throughput today. Today we support 100 gig. So we gave that for our AI intensive customer, where they need to move training data from on-prem to the cloud to train and vice versa. And it also allowed them to do that at low latency and 4x speed. Additionally, we have, for our VPN customers, we have increased the bandwidth on the VPN by 3x. So now a VPN gateway can do up to 20 gig in total, with a 5 gig per flow capacity. So this is, again, to meet the performance and scales for VPN customers. Now let's dive into application delivery. And in this pillar, we focus on applications, on how you expose your application to your end customers over the internet or even internally. And what is critical about application delivery is choosing the right way of load balancing. And we have 4 different load balancers available in Azure, starting with standard load balancer, which gives you high throughput TCP UDP load balancing. And then if you want layer 7 with HTTP, HTTPS, and TLS and SSL termination, and your load balancing capabilities, that will be the application gateway with additional of application firewall that offer you, or WAF that offer you layer 4 to layer 7 protection on top of your application gateway. If you're looking for global load balancing, or if you're offering a global service, then Azure Front Door is another capability that gives you that with caching and global availability with global anycast. Additionally, we have the traffic manager, which gives you DNS-based load balancing globally. One key thing across all the application delivery services is enabling logging and monitoring, and also enabling your health probes. So you're able to monitor your health backends, and you're able to monitor how your backends are scaling up and down. Now, moving to container space, we offer Azure Container Networking Services, which gives you filtering capabilities and monitoring capabilities, and we'll talk about that in details in the next section. But also we offer managed Cilium with ACNS, which gives you high performance. So let's talk about innovations in that space. And first one is Load-Aware Application Gateway for Container, or AGC. And in that, traditionally, Application Gateway will use round robin to distribute traffic on the backends. With Load-Aware, we're able to get a response back from the container to say if it's overloaded, like it's a 0 to 1 range. And with that, the load balancer can decide whether to send the traffic or not. So if the container is overloaded, it will avoid sending traffic to that container. And it uses the open request cost aggregation, which is a standard for load-aware load balancing. Similarly, we introduced WAF for application gateway for containers. For customers who have been using AIGC, or ingress controller. This was one of the blockers for them from moving to AGC, or Application Gateway for Containers. Now with the availability of WAF, customers can move to Application Gateway for Containers that uses as a default for load balancing in containers. In container space, as I mentioned earlier, we talk about managed Cilium with Azure Container Networking Services. With managed Cilium, we offer high performance pod-to-pod traffic via APPF. And this is like Azure managed. There's offering where you can bring your own Cilium too, but this offers a higher throughput, like 49% higher. And this is because we avoid the double in cap, and we have done optimizations in the managed Cilium. In addition, Azure Container Networking Services gives you layer 4 to layer 7 filtering capabilities, gives you advanced observability that you can integrate with Azure open source solution to monitor your container health. In security space, we're going to talk about how you scale your security, and the main thing here is using the default or the cloud native offerings for security that help you to get a better security at scale, because it's Microsoft managed and it gives you security at scale. First is Azure DDoS protection. With Azure DDoS protection, you can enable that on your VNet, and you can get like standard or premium, which have advanced threat defense and advanced DDoS tuning capabilities. Also DSR, which is a response team that can help with mitigation when DDoS happen. And also this cost optimization, cost protection built in with DDoS plan. Second is using Azure WAF for Application Gateway. WAF is available for both Application Gateway and Azure Front Door. Gives you a unified layer 4 to layer 7 firewall with URL filtering and API filtering capabilities and HTTP request filtering capabilities that you can leverage to protect your workloads behind an Application Gateway or an AFD. Again, it's auto-scalable. It's it's Azure managed, so you don't have to worry about scaling that, or you don't have to worry about capacity planning for it. Finally, it's Azure Firewall in the security portfolio. Azure Firewall is a native firewall, cloud native firewalls that give you filtering for east-west traffic or north-south traffic, and it's Azure managed, so it can auto scale up and down depending on your traffic volume. Also gives you advanced capability, including URL filtering, monitoring, and packet capturing abilities. Now let's talk about management and monitoring at scale. It's important to take in consideration that when you have thousands of VNets and network resources, management and monitoring becomes a critical part of that story. And we introduced Azure Network Manager about 2 years back with capabilities like IP address management and also route management and connectivity management that simplify your network connectivity and simplify your routing in Azure and IP address planning. Similarly, we have a portfolio of security management solutions, including Firewall Manager, DDoS Manager, and WAF Manager that help you to manage your security policies across all the different security services we talked about earlier and have a unified view or single pane of glass for your network security in Azure. Now, to talk about innovation in that space, we have introduced a Network Watcher, network filtering capabilities, because at scale, when you enable Network Watcher or VNet Flow logs, you're going to get like lots of logs that has resulted in like storage consumption, high storage consumption, high storage cost. With filtering, you're able to filter down the traffic you're interested in, and you can reduce your storage cost or storage capacity used by the logs generated from Network Watcher. So in conclusion, I want to talk like networking scale step by step, or kind of a high-level takeaways here. One is plan ahead. It's important to IP address plan your network and prepare for growth in Azure, and it's picking the right architecture and the right planning is critical. You can refer to our architecture center with a lot of documents about like how you can build hub and spokes, how you can connect in Azure, how you scale your resources in Azure. Similarly, I recommend using cloud native capabilities like NAT Gateway for egress, private link for connecting to PaaS, and Azure Firewall for security. Also, choosing the right load balancing solution for delivering your application, like whether it's Application Gateway or Azure Front Door or Traffic Manager or load balancer. whichever meets your application needs, and there's no restriction from layering this all together. Finally, using a monitoring and management solution to manage your network at scale. Thank you for joining me today. I hope that gives you a comprehensive overview of how you scale your network in Azure and how you build a scalable network in Azure, whether you are migrating or modernizing or building your next AI application. It's a pleasure talking to you. Thank you.